Hi everyone, this lesson 1.2 is shifting from our first lesson, which looked at ratio and proportions. For this lesson and the three after it, within your first unit, I'm going to now focus on geometry. Okay, so geometry does have a lot of ratios and proportions associated with it. And you'll kind of start seeing that, especially when we get into triangles. All right, but first things first, for some of you, this will be a review, and that's okay. Okay, I want to make sure everybody is at the same level in their learning. So for some of you, this will most certainly be a review. For others, it may be new. Before we start looking at geometry, I want to just go over some important concepts. Okay, I will be using these terms a lot, so it's important for you to know exactly what they mean. The first is a point. Okay, so a point is a location in space. Okay, when you talk about graphing points, and I'll talk about the Cartesian coordinate system later on, it doesn't have any width or height or length. Usually it's used as a notation. It's used as a starting point or an end point for a line, for example, or as a vertex where two lines come together when we start talking about shapes, triangles, squares, other quadrilaterals. A line is actually something that extends indefinitely. Okay, so it doesn't have a start or end point. It goes in a direction, whether it's more left to right or more up and down or a combination of the two. A line segment is what's bound by 2 points. Okay, so if you have 2 points and you draw a line in between, that's known as a line segment, and it starts and ends at points. A plane is an extension of that, and it's a flat surface, and it extends indefinitely in 2 dimensions. Okay, a plane, you can consider a line. Okay, a plane is a 2-dimensional kind of piece or slice. Okay, and you can usually within a plane, if you bound it with points on that plane, you can calculate an area. And the last item is rotation. Okay, so an angle is the amount of rotation you're going to have of a line with respect to the starting point. And we're going to get into where the general starting point usually is. And a line rotates along a fixed point, and that point is known as a vertex. Okay, so that's kind of the starting point for where the angle starts and finishes. So in order to think about angles, again, a lot of this may be reviewed to some of you, not all of you. But in order to look at angles, we need to talk about the Cartesian coordinate system. Okay, that is this image here on the right. So it's broken down into 4 quadrants. Okay, we have an x and a y axis. So the x-axis goes left to right. Okay, right here. The y-axis goes up and down. Okay, to move in the positive direction on the x-axis, you have to move to the right, and in the negative direction, you move to the left. On the y-axis, to move in the positive direction, you move upwards, and the negative direction, you move downwards. Now, when we're calculating angles, your starting point is always the positive x-axis, and typically your vertex is the actual point in the center. This is known as the origin. Okay, so if you draw a line right here, that angle would be 0 degrees. Okay, so your angle is taken with respect to that positive x-axis. Moving to here, your angle starts here and it's measured outward. Okay, and the angle is usually symbolized by the symbol theta. Okay, so as you move further and further outward, your angle gets larger. Okay, if you're in the first quadrant, okay, that means you're an angle from 0 to 90 degrees. That is known as an acute angle. Okay, I'll actually circle it in red since the angle I drew was an acute angle. If your angle is exactly between the x and the y axes, okay, which is the angle shown in blue, that's a right angle. It's exactly 90 degrees, and it is always denoted with this square on the angle. Okay, so when you see a question, whether it's a square or a triangle, if you see that notation, you know it's 90 degrees. Okay, that's provided in the question. If your angle extends into quadrant number 2, which is seen by the green, it's called an obtuse angle. And that angle is between 90 and 180 degrees. If your angle extends all the way to the x-axis in the negative direction, show that one in purple, that is known as a straight angle. It's exactly 180 degrees. Lastly, if your angle ends up anywhere in either quadrants 3 or 4, in other words, greater than 180 degrees, that's what's known as a reflex angle. Okay, so just important concepts to know as we start navigating through different rules. Okay, so you're going to start to see different relationships that form amongst angles, giving certain considerations. Okay, before we get into some relationships, what I want to do is just reinforce the different types of angles. So I've got 6 angles listed here, and we're going to classify each one of them based on the terminology that I provided in the last slide. So A, 45 degrees. Remember, an angle between 0 and 90 degrees was known as an acute angle. Okay, just remember, these angles typically look something like this because they're less than 90 degrees. For angle B, 125 degrees, so that is greater than 90 degrees, but less than 180. Okay, so in that case, that angle looks something like this, and that would be an obtuse angle. C, 90 degrees. Remember, if it's straight 90 degrees, it would have this square noted at the angle. That is known as a right angle. Okay. D, again, is less than 90 degrees. So it'd be a little bit taller than what we did in A, but again, still an acute angle. E, 185 degrees, would look something like this, right? Because the first quadrant is 90 degrees. The second quadrant goes another 90 degrees. So if it was straight, it would be 180. And then it goes further. So it goes into quadrant number 3. So that means this would be noted as a reflex angle, okay? Because it's greater than 180 degrees, up to 360. F, our last one, is exactly 180 degrees, meaning it'd be an exactly straight line, okay? And that's known as a straight angle, okay? This is just to reinforce the terminology that we had in the previous slide. So using what we know about angles, okay, there's going to be several items that usually occur when we're doing our angle calculations. And a lot of times they're dependent on whether we have parallel or perpendicular lines. So going back to our Cartesian coordinate system that we have here, the x-axis and the y-axis are perpendicular to each other. In other words, this angle is 90 degrees. All right? So perpendicular lines cross at exactly 90 degrees. Okay? Parallel lines have the exact same slope. They never cross each other, okay? So if you had a y-axis, or if you had a line drawn, okay, and let's say we draw it at this point here, straight up and down. So this is at x equals 2, okay? If that line is straight up and down, it would be parallel to the y-axis because it would never cross it, all right? So this distance would be 2, right? Because this point's at 2, x equals 2. This distance would be 2 forever. Forever and ever and ever, extending indefinitely for a line. Okay, so that is what it means by two parallel lines. In other words, they don't have any slight angle or any variation to them with respect to the other line. So using these theories with parallel and perpendicular lines, okay, we have what's known as complementary and supplementary angles. Okay, so complementary angles are when you have two lines, in this case, line OP and OQ. All I did was take the first letter extending to the last letter, or first point to the last point, and you draw a line in between. The angles, so in other words, this angle, which we'd call angle POR, I just started at one point and went in logical sequence. And your second angle, angle QOR, again starting here, QOR. If you add those together, they have to equal 90 degrees because this angle, POQ, again, you see this little square here, that angle is 90 degrees. So if you draw any line within that, the angles that it basically splits into have to equal 90 degrees. Supplementary angles is a similar concept except for a straight line, okay? So if you have a straight line, okay, that means this overall angle is 180 degrees. If you add a line here, the angles that it splits that line into, in other words, angle BAC, again, starting from here to here, plus angle DAC. You notice I use this little triangle. That is just symbolizing angle. Those have to equal 180 degrees, right? Because it split that line into two angles, okay? Those are called supplementary angles. Again, these relationships all will build on each other in these slides, and you'll see how given multiple lines, you can use these relationships to figure out angles that you didn't necessarily think were possible initially. Look at a few examples. What is the angle BAC in the image below? So what we notice here is the line DAB. It's been split, okay, by adding another line here, okay? And what we remember is for supplementary angles, that means angle DAC plus angle, you can either do BAC or CAB, it means the same thing, angle BAC, have to equal 180 degrees. So knowing the one angle, DAC, is 105 degrees plus angle BAC, that has to equal 180 degrees. Again, because these are what's called supplementary angles. So to solve for angle BAC, we just have to subtract 105 from both sides. So on the left side, negative 105 plus 105 cancels. And we're left with angle BAC is equal to 180 degrees minus 105 degrees, or 75 degrees. Okay? So let's look at a second example. what is the angle CAE in the image below? So we're looking for CAE, or this angle, okay? So again, we have a straight line, okay? DAB. But in this case, it's broken up twice into 3 angles. So we know that the angle, we'll call it DAC, plus angle CAE, plus the angle EAB, okay, this angle here, has to equal 180 degrees. So only one number is listed, but we actually know 2 angles. Remember, that square on the angle means that this has to be 90 degrees. So angle DAC is 40 degrees, plus angle CAE, which we don't know what it is, plus angle EAB, which is 90 degrees, has to equal 180 degrees. So angle CAE plus 130 degrees, I just added 40 and 90, is equal to 180 degrees. So subtracting 130 degrees from both sides, in order to have angle CAE by itself, on the left side, the 130s cancel, and angle CAE is simply equal to 180 minus 130, or 50 degrees. Okay, this was using 2 concepts here. Okay, this was a supplementary angle, okay, with a straight line, and these are also considered complementary angles. Okay, because the other side was equal to 90 degrees. So we can take this a step further. Okay, so if we've got 2 parallel lines, in this instance, AB and CD, and we have a line that crosses it. Okay, the line here is EF. That is what's known as a transversal. Okay, and there's a lot of angles here that we can notice are similar. Okay, so first item to notice is supplementary angles. Okay, so we already talked about supplementary angles, and what that means is angle 1 plus angle 2 has to equal 180 degrees. Angle 3 plus angle 4 has to equal 180 degrees. And keeping going down, angle 5 plus angle 6 has to equal 180 degrees. And angle 7 plus angle 8 is equal to 180 degrees. And that's simply because it's the transversal line, EF, split the angles here, 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 and here. Okay? So in all 4 locations. So starting with the first concept, we'll talk about vertical angles. Okay? So you'll see in vertical angles, we've got a straight line, AB, and another straight line, CD. And what a vertical angle means, okay, is if you calculate these angles out, these angles that are directly across from each other, okay, so in other words, this angle here and this angle here are equal. Okay, so angle AOC in this picture is equal to angle BOD. Looking at the image here, what that means is that angle 2 and angle 3 are equal. Angle 1 and angle 4 are equal to each other. Angle 5 and angle 8 are equal to each other. And angle 6 and angle 7 are equal to each other. Okay? This is just giving you more methods to figure out all these different angles. Okay? Corresponding angles are angles that are in the exact same location. Okay, so in other words, this angle here and this angle here are in the same location, right? They correspond to each other. If you went further and had a third line, okay, with another one, we'll call it 9, that would also correspond, okay? Because these are all straight lines, remember, that's the important thing to keep in mind. So what that means is that angle 2 is equal to angle 6. Similarly, angle 3 is equal to angle 7. And another instance, angle 4 is equal to angle 8. Okay? You can also write it as angle 1 is equal to angle 5. Okay? Because they're in the same location, just on a different parallel line. Okay? One is on the parallel line CD, one is on the parallel line AB. But remember, those lines are parallel. Okay? So that angle will never change, right? Because the lines are parallel to each other, and this distance is always the same when they're parallel. Alternate interior angles, okay, mean that angle 3 and angle 6, they alternate of each other. So a good way to see this, okay, is this makes a Z. Okay, so these two interior angles on the Z must be the same. Okay, so that means that angle 3 is equal to angle 6. And what it also must mean is, remember, okay, these angles are adding up to 180 degrees on this interior. So what that also means is that angle 4 has to be equal to angle 5, okay? Because remember, angle 3 and angle 4 add up to 180 degrees. Angle 5 and angle 6 add up to 180 degrees, okay? So if one of those two angles is the same as one on the other one, okay, that means these angles have to be the same too, because they both add up to 180 degrees. So that's alternate interior angles. Similarly, alternate exterior angles is just looking at the ones on the outside, okay? So picture points 3, 4, 5, and 6 being inside these parallel lines, and 1, 2, 7, and 8 being outside or exterior to it, okay? The same rules apply here, okay? So angle 2 is equal to angle 7 because they correspond to each other. And angle 1 is equal to angle 8, again, corresponding to each other. So these are a lot of different rules that you're going to see, and you can apply them in any different manner that you like, okay? We're going to do an example where I'm going to run through all the different angles in the next slide. But keep in mind, I'm going to do it one way, okay? It isn't necessarily the only way. You can see that there's all these different rules that apply to angles, okay? So there's more than one way to solve these questions. And again, regardless of how you answer the question on a test, okay, you don't have to do it my way if you're getting to the answer, as long as you're showing your work, okay? So let's look at an example. Given the image below, calculate the remaining angles 1 through 6, okay? So a couple items to note. Line AB is parallel to CD, okay? That's what this symbol means, the two dashes like that. If you were to say perpendicular, you'd see it written as AB with lines at 90 degrees. That means perpendicular to CD. In this case, it's written as parallel. So we're given that it's parallel, and we're given that one of our angles is 62 degrees, okay? So we need to figure out angles 1, 2, 3, 4, 5, and 6. So I'm going to start with angle 1 because we're given 62 degrees. And we know that vertical angles, so in other words, this angle here and this angle here, have to be the same, okay? So that means that angle 1 has to be equal to 62 degrees, right? The next item that I'm going to look at, and again, this is me kind of jumping, is I'm trying to fill in the blanks. So I'm going to write this as 62 degrees, okay? Next item I'm going to look at is actually going to be angle number 5. And the reason for that is we know that for angle number 5, we have 62 degrees plus angle number 5 have to equal 180 degrees, right? Because they're supplementary angles. So if we solve for it, I'll move item 6 out of the way. By subtracting 62 degrees from both sides of the equation, these two cancel. Angle 5, okay, is equal to 118 degrees. So this is why I wrote all of the angles out, okay? Because you can solve this any number of ways that you choose to, okay? Again, the next item I'm going to now go for is angle number 6. I'm kind of completing this top piece before I go to the bottom piece. Okay, so again, we know that angle 1 plus, we see this square here, that means that's 90 degrees, so plus 90 degrees, plus angle 6 have to be equal to 180 degrees. Again, looking at supplementary angles. So angle 1 is 62 degrees, plus 90 degrees, plus angle 6 is equal to 180 degrees. So this is equal to 152 degrees plus angle 6 is equal to 180 degrees. So to solve for just angle 6, I'm going to subtract 152 degrees from both sides of the equation. So these cancel. And angle 6 is equal to 28 degrees. Okay? So you can see here that I'm starting to build a picture here. Okay? The next item I'm going to note, okay, again, remember, I'm looking at, okay, alternate interior angles. Remember the Z pattern I talked about. So if I do that, okay, this angle and this angle have to be the same. So what that means is that this angle here is also 62 degrees. Okay, so I can then solve for angle number 2. And if I do that, okay, for angle number 2, again, using supplementary angles, I have angle 2 plus, I'll give myself a little more space, you'll see why. Angle 2 plus 62 degrees has to equal 180 degrees. So to solve for angle 2, I subtract 62 degrees from both sides. So on the left side, they cancel. And angle 2 is equal to 118 degrees. Okay? Similarly, okay, what you're going to see here is I'm going to draw that same Z again, right? These are alternate interior angles. And what that means is this angle here, angle 6, has to be equal to angle 3, right? Because they're alternate interior angles. So that means angle 3 has to equal angle 6. I'll write it as angle 6, which is 28 degrees. Okay, again, some of these concepts, this is the method I'm using. You'll notice I'm not necessarily doing them in order. You absolutely could find a way to do them from 1 to 6. Okay? So we have one angle left, and that's angle number 4. And again, using supplementary angles. Angle 3, which is 28 degrees, plus angle 4 have to be equal to 180 degrees because it's supplementary angles. So to solve for angle 4, I'm going to subtract 28 degrees from both sides. Okay, so I can get angle 4 by itself. These 28s cancel, and we're left with angle 4 is equal to 152 degrees. Okay, again, I can't stress this enough. This is one way to look at this style of question. Okay, you can go back, okay, look through my answer, and you could do it a completely different way. Again, it doesn't matter to me as long as I see your work and I see you get to these numbers on a test. Okay, so that was it for our second lesson, okay, on lines and angles specifically. In the coming lessons, we're going to start looking at more specific examples, triangles, quadrilaterals, and some solid figures. So just like the last lesson, I picked specific problems that I feel are appropriate for you given what we've learned in the course so far. And geometry, or this second piece of our first unit, is actually chapter 2. So you'll find these in exercises 2.1. Okay? Thanks, everybody.